Okay, guys, gals, welcome back. Hopefully, you were able to spend a few minutes and sketch out these free body diagrams. This one right here is for the 6 kilogram block. So, as you can see, remember the acceleration was positive because it's moving to the right across that table. So, here we have, it's on the surface, so we have, obviously, it has weight, mg. And it has a normal force. It's on a surface, so there's a normal force perpendicular. Over here, we have a force of friction. Since it's moving, we know it's going to be kinetic friction. We don't know what it is or how much it is, but we know it's there. And over here, we have a force that is being applied. In this case, it's the tension in the cable. So I have this force of tension, or TEN. So there's my free body diagram for the 6 kilogram block. Over here, hopefully, you can see this. I have the second block, the 5 kilogram block. Again, we have denoted that the downward motion is positive for that block. So acceleration, is positive, downward. So here's my free body diagram. Obviously, I have weight that's downward, mg. It's not on a surface. There's no normal force. It's not bumping against anything. So there's no other forces. So we have the force that's being applied back up, and that's our force of tension. That's our tension force. So if you take a look at these are the two free body diagrams that we should have drawn. Check your work and make sure that you understand what's going on. All right, the next step is to take a look and do our force equals mass times acceleration for each block. So, for example, in the x direction, we have the block that's on the table. So if we take a look at that, the net force is equal to the mass times acceleration. Remember, net means the sum of all the forces acting on it. If you use your free body diagram, this is what you probably ended up with. You have a force of tension that was positive, remember, it's positive, minus the force of friction. Again, we don't know the amount yet, but we do know it's there. And that's going to be equal to mass times acceleration. So if you look back at your free body diagram, this is sort of this is what's being explained. We have the tension force that's pulling it, and that's a positive. So positive T, minus whatever that kinetic friction is. Those are the net forces acting on that block. Because you know the normal force and the weight, they cancel each other out, so they're a non-factor. Equals m times a. Well, let's jump over. Let's take a look at the second block. And that would be in our y direction. Well, there's no forces acting on the second block in the x, so we know we're just dealing with the y. So again, using Newton's second law, we'll set this up. So that means that going down, we have, moving downward, we had the force of the tension. Now, we know that moving down, we have the weight, and that weight wants to move down. However, the tension force is acting opposite. So we would subtract or say minus the tension. So the net force of the second block, the 5 kilogram block, its weight is what's moving it down. But it has a tension force that's acting in the opposite direction. And if you remember, we said acceleration was down. And this is going to be equal to m times a. So, using Newton's second law for our pulleys, we took each block, free body diagrammed it, and then we set up our F equals ma equation with our net forces here and here. So we have two separate equations for Newton's second law. And that should be where we are right now. Let's take a minute, make sure you're okay, and we'll be right back.